NCBM 0324, Section 1.5, Basics of Factoring Polynomials, Part 4. Let's practice some more of this factoring in this GCF idea. Example 7, we want to factor each expression, and we're going to factor as much as possible. Part A, we have 8x squared minus 4. Like we did on the other ones, we're going to look for a GCF, just to make it as simple to start with as possible. And I'm noticing only the first term has x squared in it, the second one does not, so my GCF will be a number. And then between the 8 and the 4. And this looks a little familiar. Think about it another way though. Again, we're looking for the greatest common factor. So what number, the biggest number possible, will divide into both the 8 and the 4? What's going to be that greatest factor? Well, I know 4 goes into 4 and 4 goes into 8, so I think my GCF is 4, right? Which we saw in our one of our last examples with those trees. We can also find it with the factor tree. But I think now I can see it pretty quickly. It's going to be 4. So then, my 8x squared minus 4, I'm going to undo the distributive property. So here comes 4 is my GCF, parentheses. And what's left over when I pull that 4 out of the multiplication? Well, 8x squared divided by 4 gives me that 2 from the numbers, and then the x squared is still attached. Then the minus 4, so we're undoing that multiplication, so I'm going to divide 4 by 4, that gives me the 1. Of course, the subtraction goes along with it. So there is my factorization. Can I do anything else with the 2x squared minus 1? For now, there's no other values in common, so that's where our answer stops. Let's look at part C. Let's jump to part C, just because it has more than one variable. That seems interesting. So in part C, we have 4xy minus 3y plus 19y. All right, so looking at our terms, looks like we have the 4, the 3, and the 19. Similar to what we reasoned out in the last video, that 3 is prime, the 19 is prime. So it looks like our GCF, at least the number part of it, is just going to be a 1. There's no value number-wise that they all have in common in terms of factors other than 1. But my other pieces may have something to do with this. Looking at the variables now, we haven't really considered variables in our examples too much, but look at the variables that these 3 pieces have. We have x times y minus 3 times y plus 19 times y. So all 3 of these terms have a y in them. So it looks then like our GCF, greatest common factor, is simply y, or 1 times y. If you like the number in front, we can write 1 times y, but that simply gives us y. So GCF, sometimes it's a number, sometimes it's just the variable part. So then I can write 4xy minus 3y plus 19y. Factor out that y, undo that distributive property. So if I factored out y from the 4xy, I have 4x left over. The multiplication of the y got pulled forward. Minus 3 times y, well, that's just minus 3. Again, the y got pulled forward. Plus 19y, well, the y pulled forward, so then I have left over 19. And then looking inside of my parentheses, let's see what else we can do in there. We do have some common terms. We have the negative 3 plus 19 that I can combine. And that will give me 16. All right, looking good. Let's continue to check. Can I factor this even more? Is there anything else I can do with the factorization here? Well, from that combination, the combining of the constant terms, the negative 3 and the 19, we came up with a 16. Now, how does that compare with the 4 in front of the x? Well, 4 and 16, between those values, I have a GCF of 4. So then I can pull that 4 forward as well. I can continue the factorization. We'll do 4 times the y, still multiplication because we're undoing the distributive property, but I can pull that 4 outside of the parentheses, leaving behind x plus 4. And now, is there anything else I can do with x plus 4? Nope, there's no other multiplications to deal with, no other powers, and this would be my factorization. 4y times x plus 4. Now that was one way, one path we took. We could, at the very beginning, up here, notice that the minus 3y, the plus 19y, would give us a plus 16y, and then that would have changed our GCF at this point, but either way, we would have ended up in the same place. Right? It would have all together ended up in the same answer, the same factorization. Let's jump to number 8 now. And I'm going to skip part A of number 8 because I'm looking at part B has a lot of different powers. We haven't talked too much about powers yet, so let's look at part B. We're factoring still as much as possible. And in part B, we have 21x to the fourth minus 18x cubed plus 27x squared. So looking at the GCF, we want to consider what do all of these terms have in common? Well, I'm going to compare the 21, the 18, and the 27. So 21, 18, and 27. I know it's not going to be a 2, and 2 is a factor of 18 because 18 is even, but 21 and 27 are not. What about 3? Does 3 go into each of these numbers? Yep, 3 times 7 gives me 21. 3 times 6 gives me 18. And 3 times 9 gives me 27. So it looks good. Is there anything bigger than 3 that they all have in common? No, right? 3 is the greatest number that can go divided nicely into 21, negative 18, and 27. All right. Is that it? Is that all they have in common? Let's check our variables. So the 21x to the fourth. So when we write x to the fourth, we're saying we have x times x times x times x. X multiplied 4 times. When we write x to the third, that's x times x times x. And then x squared is x times x. So looking at all of these x's, they're all over. But we want to always figure out the common parts. How many do they have in common? Well, the first one has 4, then 3, then 2. So can I say that they all have 4 x's in them? I can't, right? The other ones have less than that. Can I say they all have 3 x's? Well, this one has 3. The first one has 3, but the last one doesn't. Now, do the first two terms both have x times x? And they do, right? They at least have x times x in common. So this is the common part. That's what we mean by the common factor. We're going to multiply that 3 with an x squared. They have at least x squared in common. So when I go to factor then, 21x to the fourth minus 18x cubed plus 27x squared. I'm going to factor out the 3x squared, 3 from the numbers, x squared from the variable parts. So from the 21x to the fourth, divide that by my 3 in the number, that's 7. 7 is the rest of my multiplication there. Then I had x to the fourth, but I'm pulling 2 of those x's forward, x times x forward, and that leaves how many x's left behind? X times x, which is x squared. Okay, minus, let's see what happens with the 18 x cubed. See, 3 divided by 18 is 6. X cubed divided by x squared. So if I have 3 x's, I'm pulling 2 of the x's forward. There's only 1 x left behind. Then our last one, 27 divided by 3, well, that's 9. And then the x squared divided by the x squared, we're pulling both of these x squares forward. So there's just the 9 by itself. So there it is. There is our factorization of that initial expression. This is a really good place, by the way. Just a reminder that if you're uncertain, if you don't know if your answer is correct, if you pulled the value forward enough or correctly, remember you can always check by multiplying it through. Take your answer and distribute that GCF that you just finished undoing, right? 3x squared times 7x squared, well, it's 21x to the fourth. 3x squared times negative 6x, 3 times 6 is 18, x squared times x is x to the third. And then 3x squared times 9, 3 times 9 is 27, and then the x squared is being multiplied. So checking is always really nice if you're uncertain of some of these problems. The last one, part C. We have 4 minus 2x squared plus x squared times y to the third minus 2 times y to the third. So mixtures of x's and y's. We have a lot of variables here. We have some numbers, some that don't have variables. The 4 is just a constant. And we have a couple of different powers here. One other difference, by the way, is the fact that I have 1, 2, 3, 4 parts to this expression. So that's something to kind of think about. Now let's start with the GCF though. GCF, we're looking for the greatest common factor. So what do these all have in common? Well, I notice that y cubes are right here. The last two have a y cube, but the first two don't, so that won't work. Well, these middles have x squared, but the other ones don't. Okay, that just won't work either. The 4, the 2, and the 2 over here, those are all even numbers. So maybe my GCF is 2, except this third one doesn't have anything either, right? It doesn't have a 2 in front of it. It's technically a 1. So then 2 won't work. So if our GCF is simply the number 1, right? That's our standard if everything doesn't match up together here. We would say that this might be prime. Now, something that we mentioned a little while ago is that this expression has 4 terms. And when you have 4 terms, you have a couple more methods of potentially factoring. So what I'm going to say on this one is for now, we cannot factor. This is a good reminder, cannot factor, that this section is just about the basics. You are going to learn about these other methods later on in the semester. So keep that in mind that if the GCF is 1, we're going to have to potentially still look at a few other methods in the future, right, in our last half of our class here.